Hello everyone, welcome back to my YouTube channel. So today we'll be continuing our topic that is work and energy. So this is part 2 of the chapter. In previous part we have discussed about basic concepts of work. If you haven't watched the part 1, do watch it. The link is in description. So before moving to today's lecture, we will just record what we have learned in the previous part. So in the last lecture we started the topic work and energy. So the part 1 of the chapter is about learning about work. So in previous part, we defined work mathematically as product of force and displacement. And this force is nothing but that component of force which is in the direction of displacement. Okay. Then second thing we discussed is about the unit of work. So unit of work is joule, which is also known as Newton meter, or you can call it as kilogram meter square per second square. And the CGS unit is ergs, which is dyne centimeter or gram centimeter square per second square. And then we discuss about the relationship between joule and erg. So 10 raised to 7 erg is equal to 1 joule, or you can say 1 erg is equal to 10 raised to minus 7 joule. Okay. Then next thing we discuss that if theta is equal to 0 degree, then work done is equal to F into S, that is maximum work done. And if theta is equal to 90 degree, then work done is equal to 0, that is equal to minimum work done. Okay, so these all things we have discussed in the previous lecture. So today we'll be discussing the next part of the work, that is types of work, and we'll be solving some numericals based on it. So let us discuss the types of work. So when the force and displacement are in the same direction, that is theta is equal to 0 degree, the work done by the force is positive. Okay, same direction, it means this is the direction of force and the direction of displacement is also the same. So the angle formed between the component of force and the displacement is the same. So here the theta is 0 degree. If this is the case, then we call it as the work done by the force is positive work. Next, when the force and displacement are in opposite directions, that is theta is equal to 180 degree, the work done by the force is negative. So here the direction of force is in this and the direction of displacement is opposite. So here I can say this is the direction of force, this is the direction of displacement. So the angle formed between force and displacement is 180 degree. So if this is the case, the work done by the force is negative. And the last type of work is zero work, when the applied force does not cause any displacement, or when the force and displacement are perpendicular to each other, that is theta is 90 degree, then the work is said to be zero work. For work done by the force is 0. So here there are two cases. First case is this is your object and you're applying force here 3 Newton and from here also 3 Newton. So here from opposite sides you're applying the force, same force you're applying. So there will be no movement in the object. So basically this will be 0 work. And second case is that your force is in this direction and displacement is in this direction. So they both are perpendicular. That is theta is equal to 90 degree. Then also we can say work done is equal to 0. Okay, I hope you understood what are the types of work: positive work, negative work, and 0 work. So to understand this concept more clearly, you can see the diagram on the screen. The first diagram, you can see the direction of force is shown by red color and the direction of displacement is shown by blue color. And the angle formed between the two vectors is less than 90 degree. So if it is less than 90 degree, it means the work done is positive. Okay, so this is our positive work done. In the next diagram, you can see the angle formed between the direction of force and the displacement is 90 degree. So here the work done is 0. So 0 work done. Whereas in the third diagram, you can see that the angle formed between the force component of force and displacement is greater than 90 degree. So here the work done is negative. So I hope you understood what are the types of work: positive work, negative work, and zero work. Now let us see some examples related to this. Find whether work is positive, negative, or zero. Person moving along circle from A to B. Now if you imagine a circle here, suppose this is point A and this is point B. A person is moving from A to B. So there is a displacement of person and the direction of force is also in the same. The direction of force and the direction of displacement both are in the same direction. So I can say this is a positive work. Okay, next. A person completing one circle and returns to position A. Now this is different from the above case. Suppose this is a circle. This is a point A. Now they have told us person completing one circle and returns to position A. So from A it has started and again it returns to position A. So here the displacement is itself zero. The initial position and the final position both are same. So your displacement is zero. Now if the displacement is zero, the work done will be zero. So this is the zero work done. Because W will be equal to force into displacement. Displacement is zero. So work done will be zero. Next, person pushing a car in forward direction. Now this is a car. For example, this is a car. The person is pushing the car in forward direction. So car will move in forward direction only. So the direction of force and direction of displacement are same. So again, this is a positive work. Okay. Next, motion of a clock pendulum. Now here you can see a pendulum. I will erase these annotations. Okay. So here you can see the pendulum. Motion of a clock pendulum. Now as you can see here, the position of the pendulum at this moment is here, and again it goes to another end. Again it comes back to the same end. So at one position it comes back again and again. So the motion of clock pendulum is a zero work done because at the same position it comes back at a certain interval. Okay, suppose this is our starting position. So again after a few seconds it will again come in that position only. So here the starting position, final position are same. So I can say there is no displacement of the object. So motion of a clock pendulum is a zero work done. Okay, next, catching the ball which your friend has thrown towards you. Okay, now suppose this is your friend and this is you. Now the friend has thrown ball towards you and you have to catch it. Now displacement of the ball is in this direction and you are applying force to catch the ball in this direction. So the displacement is in this direction and force is in this direction. They are in opposite direction. So this is a negative work done. So I can say this example is of negative work done. Okay, next, stopping a moving car by applying brakes. So for example, this is your car and the car is moving in this direction. But as soon as you apply the brakes, force will act is in this direction. So here the direction of force and direction of displacement is opposite. So again, I can say this is again a negative work. So I hope you understood how we have classified the following examples as a positive work, negative work, or zero work. Now let us move to the further topic. Suppose an artificial satellite is moving around the Earth in a circular orbit. As the gravitational force acting on the satellite along the radius of circle and its displacement along the tangent to the circle are perpendicular to each other, the work done by the gravitational force is zero. So here you can see in the image, this red color arrow This is nothing but a gravitational force. Okay, so this gravitational force is pulling the satellite towards the Earth. So this is the gravitational force which is acting towards the Earth. And the displacement of the satellite is along the tangent of the circle. And you can see that the angle formed between the component of force and the displacement vector is 90 degree. So therefore, I can say work done is equal to 0. The work done by the gravitational force is 0. So this is a give reason which can be asked in your exam. So now let us move to the numerical parts of the chapter. So in the first part of the chapter, we have learned about work, and we'll solve now numericals related to work. So here is your first numerical. Ravi applied a force of 10 Newton and moved a book 30 centimeter in the direction of force. How much was the work done by Ravi? So here I will write a given part. So given part is they have given us the force applied, that is 10 Newton. Then they have given us a displacement, that is S, that is equal to 30 centimeter. Now if you can see, the force they have given in SI unit Newton, but the displacement they have given in centimeter, that is CGS unit. So we need to convert that CGS unit into SI unit. So we know the conversion factor, 1 meter is equal to 100 centimeter and X meter is equal to 30 centimeter. So we know that 1 meter is 10 raised to 2 centimeter. So what will be 30 centimeter? If you want to convert meter to centimeter, you multiply it by 100. If you want to convert centimeter to meter, you divide by 100. So here, if you convert 30 centimeter into meter, you have to divide by 100. So the answer becomes here 30 divided by 100 meter, which is equal to 0.3 meter. Now both the units are in SI system. Force is also in SI unit and displacement is also in SI unit. Now we can apply the formula. So we need to find the work done. To find work done. So we have the formula for it. Work done is equal to force into displacement. So work done will be equal to force is 10 Newton into displacement is 0.3 meter. So 10 multiplied by 0.3 will give you 3. So the work done will be 3 Newton meter, or you can write 3 joule, or you can write 3 kilogram meter square per second square. So any unit is acceptable. Now let us move to the next question. Question number 2. Praveen has applied a force of 100 Newton on an object at an angle of 60 degree to the horizontal. So that is not 600, it is 60 degree. The object gets displaced in horizontal direction and 400 joule work is done. What is the displacement of the object? Cos of 60 degree is equal to half. So in this case, they have given us the angle between the force and the displacement. So let us write the given part here. Given part is force, that is equal to 100 Newton. Then they have given us angle theta, that is equal to 60 degree. The object gets displaced in horizontal direction and 400 joule work is done. They have also given us work, that is 400 joule. What is the displacement of the object? They are asking us to find the displacement. S. The formula we'll use. What is our formula? Work done is equal to Fs cos theta. So work done they have given in joules. It is a SI unit. Force they are given in Newton. It is also SI unit. So both units are in SI. So we'll write work done is 400. Force is 100. Displacement we have to find and cos of 60 degree. So 400 is equal to 100 into S. Cos of 60 degree, they have given us 1 by 2. So from here we will get 400 divided by 100 into 2 is equal to S. So lastly, S will be equal to 4 to the 8 meter. So last statement you can write the displacement of object is 8 meter. Let us move to the next question. Question number 3. A force of 50 Newton acts on an object and it displaces it by 2 meters. If the force acts at an angle of 30 degree to the direction of its displacement, find the work done. So let us write the given part. So given force is equal to 50 Newton, displacement is equal to 2 meter, and theta is equal to 30 degree. And to find work done. So we have the formula, work done is equal to Fs cos theta. So work done will be equal to 50 into 2, both are in SI unit, into cos of 30 degree. Now in the question they have not mentioned value of cos 30. So just remember the table, 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 upon root 2, cos 30 is half, and cos 90 is 0. So this is the table you have to remember. If the value are not given, in that case, you have to remember these values. So cos 30 is root 3 by 2. So my work done is equal to 50 into 2 is 100. Cos 30 is root 3 by 2. So if you simplify this, work done will be equal to 50 root 3 joules. This is your answer. No need to substitute the value of root 3. Let it be. Let us move to the next question. Question number 4. Sahil applied a force of 20 Newton and moved a book 40 centimeter in the direction of force. How much was the work done by Sahil? So again, simple question. Given part is force applied, that is 20 Newton. Book, moved a book 40 centimeter. So displacement is 40 centimeter. Again, this is a CGS unit. If we convert into meter, it will be 0.4 meter. You have to shift 2 places, 10 raised to minus 2. Then how much work is done by Sahil, that we have to find. So simple formula, work done is equal to F into S. So work done will be equal to force is given 20 into displacement is 0.4 meters. So your answer will be 8. So work done is 8 joules. This was a simple question. So I hope you understood the numericals of work done. So this is the end of today's lecture. I hope you understood and find this video helpful and interesting. Do like, share and subscribe our channel for more such videos. Thank you.